They are eruptions so vast, so earth-shattering, they have changed the history of our planet. Mass extinctions, climate collapse, toxic mayhem. Experience Earth and the solar system at their most extreme in supervolcanoes. The Earth we see around us is a thin disguise. It masks a monster. Beneath the calm, beneath the surface, a fury is building. It's 74,000 years ago on the island of Sumatra, along the eastern rim of the Indian Ocean. All around are signs of the tension rising deep below us. Seismic tremors rattle the landscape. Vents of sulfurous gases have begun to open up across the mountainsides. The clock is ticking down the final moments of a giant's fitful slumber. An immense mass of molten rock is rising to the surface. Cracks in the earth form. Escape routes open. Lava and hot gas begin to pour out. This volcano, known as Toba, has exploded 3 times before in the last million years. This time, it will earn a rare distinction, a supervolcano. Seething from a crater nearly 100 kilometers long, giant columns of smoke and debris fill the skies. Over 14 terrible days, Toba blasts out nearly 3,000 cubic kilometers of ash and rock. 1,000 times more than the Mount St. Helens volcano in the year 1980. It is the largest volcanic eruption the world has known in at least 25 million years. The eruption spreads a thick blanket of ash over an area half the size of Europe. Hanging in the upper atmosphere is a dense layer of soot and smoke, blocking the sun for years to come. Toba's grim aftermath is a global cataclysm. The planet plunges into a volcanic winter. Average temperatures fall by up to 10 degrees Celsius. All that rains is falling ash as drought sets in across the tropics. It does not let up for perhaps 1,000 years. Scientists believe that Toba's wrath was felt as far away as Africa by our own ancestors. In the dark years immediately following the eruption, their food supplies dwindle. It's an age defined by a dramatic crash in their population. The Toba eruption may have brought the human species perilously close to extinction. What causes a supervolcano? The answer begins with the birth of our planet some 4.5 billion years ago. It happened in a swirl of debris left over from the formation of the sun. Amid the chaos of the early solar system, gravity drew together clumps of rocks and dust. Countless objects collided and fused. Each collision generated heat. Under the barrage of impacts, a fiery young planet formed, molten at first. In time, the impacts decreased. Earth's surface gradually cooled, but its interior stayed hot. To this day, heat energy rises from deep inside the planet, a vivid reminder of the fires that burn within. The heat escapes in part through volcanoes, especially along the outer rim of the Pacific Ocean. Here is the notorious Ring of Fire. To see the furnace that powers its volcanoes, peer inside the planet. The heat moves up through a vast middle region called the mantle. It punches through where Earth's crust is thinnest in the middle of oceans. That causes massive plates that line the surface to push apart. Along the Ring of Fire, these oceanic plates collide with thicker continental plates. They thrust down into the Earth, carrying with them volcanism's secret ingredient, water. Some rocks, when mixed with water, melt more readily. They form a reservoir of magma that can fuel a volcano. It's an elaborate chain of events that Toba took to an extreme. As the molten rock and debris is blasted into the air, the entire volcanic mountain range collapses down, creating an immense cauldron-shaped basin. Water and heat are the agents of change for a world that's still a work in progress. Earth is not the only one. Welcome to Triton, Neptune's otherworldly moon. With surface temperatures at minus 235 degrees Celsius, this is no place for lava to flow. Instead, volcanoes of water ice shower the landscape. On Triton, it's the geysers that qualify as super. They can blast liquid nitrogen at almost 700 kilometers per hour to a height of 8 kilometers above the surface. Some volcanoes on Jupiter's moon Io have plumes of escaping gas that reach 500 kilometers above the surface. If on Earth, they would rise above the International Space Station. What powers Io's eruptions looms on the horizon. Jupiter exerts a massive tug on Io's core, generating heat. Much of it escapes in the largest volcano in the solar system, known as Loki. It may have formed when an impact blew a hole in Io's thin outer crust. There are traces of volcanic activity on Mars, Venus, several moons of Saturn, and Jupiter, and in the past, even our own moon. But it's Earth that may bear the deepest scars. The most destructive volcano known in our planet's history took place in what's now Siberian Russia. Wind back the clock to the time of the eruption, 250 million years ago. all of Earth's land masses were joined together in a supercontinent known as Pangaea. It was the end of a spectacular period known as the Permian. That was a time when life on Earth ran riot. Amphibians and early reptiles flourished, including the ancestors of dinosaurs and mammals. Forests and swamps saw an explosion of insect species. Fern plants, dominant for eons, were beginning to give way to conifers and palms. The oceans brimmed with life's bounty as well. Amid vibrant coral reefs, a wide variety of invertebrates and fish inhabited the open water. Here was Earth in all its glory. Then, in the geological blink of an eye, it was over. Up to 70% of all species on land and 90% of marine species disappeared. Ecosystems around the planet collapsed in a mysterious blight called the Great Dying. What happened? Scientists believe that a broad plume of rising magma pushed toward the surface. When volcanic formations like this spread out, their energy dissipates. But imagine if instead that their tentacles rose and exploded as one in a sprawling supervolcano. Here was hell on Earth. A series of small eruptions generated 1,000 times more lava than the Toba volcano. They choked the atmosphere with carbon dioxide and methane gas. Global temperatures soared. The oceans turned acidic, their waters depleted of oxygen. The Earth belched deadly toxins, including high levels of mercury. Through the history of our planet, eruptions on this scale are thankfully rare. Could one happen now? The answer is a secret in plain sight. Visitors to Yellowstone National Park in Wyoming may never suspect they are atop one of the world's largest active volcanoes. Its legacy is written across scenes like this, the fabled Yellowstone River. The heat below softened layers of volcanic rock. Catastrophic flood at the end of the last ice age then gouged out this spectacular canyon. All around, thermal energy is underfoot, like a pressure cooker gathering steam. it escapes in smoldering cauldrons, in spectacular geysers that can blast hundreds of feet into the air. In primeval hot springs laden with sulfur that simmer near the boiling point. We venture to Yellowstone to admire this thermal spectacle. Imagine if we could follow it down to its source. Surface water seeps into the ground, moving through cracks in the underlying rock. A kilometer below, the water enters layers of heated rocks, then shoots back to the surface. Deeper still, 10 kilometers down, are the upper reaches of an immense plume of magma. It's over 100 kilometers wide and 400 kilometers deep. Yellowstone has erupted time and again over the last 18 million years. Several have followed the same tripwire events that triggered Toba, the sudden release of large amounts of magma, the collapse of the land, and the rise of a supervolcano. Yellowstone is overdue. It may not erupt again for hundreds, even thousands of years. Still, scientists are watching for early signs. Earthquakes, rising heat, the restless stirrings of a planet under pressure. Yellowstone's geysers, like Old Faithful, remind us that someday, once again, the planet will vent its rage. Supervolcanoes may be rare, but the fury that fuels them is ever present. If science tells us anything about them, it's that when the next one does erupt, life on this planet will be forever changed.